Howdy. Thank you for tuning into the video today, where I detail the water level controller for my ESET462 final project presentation. Included there is the demo link to how I actuated the project. The project description looks a little bit different there than the conceptual block diagram, as you can see. Some changes from the original proposal was a shift to the TOF sensor, the change from a two-water reservoir system to a different water reservoir system. I originally planned to use a solenoid valve to create bidirectional flow, but instead decided on a drill pump to create bidirectional flow. That drill pump has a constant 1 gallon per minute volumetric flow rate out of it, and it was seen that the system response while tuning generated a good timely response in order to reach a steady state value. In this project, the purpose was to generate a 330 millimeter distance in between the sensor apparatus that was set up and the actual height of the water in the tank. This is the original flow chart, and although the solenoid valve was not used, turns out that that disturbance of having the constant volumetric flow rate was actually inserted into the dynamics of the plant system there, while having the controller contain the PID terms for the specific gains which were necessary to be ascertained. The pump PWM was not realized. Instead, a sensor value generated an error value. That error value was multiplied by the specific gains, which were ascertained in the controller. And then this control signal was sent to the control pump, the quiet quad, and this pump generated a specific volume into the control volume tank. Here is the original timeline, and I'm recording this video on November 18th, so this can be considered a success. The timeline did not go exactly as planned because material selection, acquisition were left up to the experimenter in totality, as well as the cost, which was a large issue given that this was a self-funded project. Conclusively, here are the untuned time response for the PID controller. These values were chosen and able to see the response here. Seems as if there's a lag in between the error and the control response, and from that it was garnered that the terms for KP, KI, and KD needed to be larger in order to make sure that there is a steady state error of 0, as well as a faster time response. This time response, although it looks like the values reach where they need to be, it should be noted that the time response for this was drastically too large. The next iteration conclusively had very large parameters. These parameters were generated by a Python code generated by myself. Turns out that since the error of the TOF sensor was a little bit too sporadic due to the infrared refraction off of the moving water at the top of the tank, that instead generated a pretty sporadic control signal, especially with how large the parameters were. And thus, it was conclusive that there needed to be more tuning for this system. Finally, here's the system that was considered tuned. It's considered tuned because at the beginning you can see when error spikes, there's a very fast response into the negative region, and then it became a very positive response, almost too large. However, this created a lot of oscillations, which were okay since a fast time response seemed to be most important to the person who tasked us with this experiment. As we can see at the very end of the period there, it seems as if the control signal is returning towards that zero line there in the middle. And thus, it's conclusive to say that a stable system was reached and that the oscillations would return to zero. Here are the works cited that I used. Thank you very much for listening and have a great rest of your day.